Hello developers, this is Chris here at Dimensionscape, and today we're going to look at setting up Haxe on Windows and creating our first OpenFL project from HaxeDevelop. In later videos, we will look at other IDEs and operating systems, but for today only, we will just be focusing on HaxeDevelop for the Windows platform. In this video, we will set up our environment, handle introduction to HaxLib, install OpenFL, and build a simple hello world. First though, I'd like to talk a little bit about Haxe and OpenFL for those of you who are unfamiliar and might just be discovering it for your first time in this video. Haxe is an open source, high-level, strictly typed programming language with a fast optimizing cross-compiler. Haxe can build cross-platform applications targeting JavaScript, C++, C#, Java, JVM, Lua, PHP, and Air, allowing access to each platform's native capabilities. Haxe provides its own VMs such as Hashlink and Neko, but can also run in interpreted mode. Code written in Haxe can be easily compiled to any target Haxe supports. Haxe can be used to build games and apps for almost any modern device and the web as a reliable open source technology that's completely free to use. Haxe also has many free libraries powered by the Haxe community, which are made easily accessible by the HaxeLib package manager. That is something that we will be able to get into in just a little bit. OpenFL is a powerful library and toolset for Haxe that enables creative expression for desktop, mobile, and the web, empowering developers to create performant applications for games while publishing to native and HTML5. OpenFL is primarily based on the once popular Flash API that incorporates a simple, familiar workflow and accelerated development, even opening the possibility to leverage Adobe Animate as an integrated art pipeline. As a flexible open-source development solution, OpenFL is backed by a vibrant community of experienced and reliable developers dedicated to enriching the technology and maintaining its continued success for the future. Due to its portable cross-platform nature, developers can build software for almost every platform imaginable, including Windows, Mac OS, Linux, Android, Air, and the web, encouraging you to bring your creative vision to life on desktops, tablets, phones, and even consoles. Now that our introduction is out of the way, let's get started. So the very first thing that we want to do now is download and install Haxe. You can find the links for all the relevant material today down in the video description below. Simply go to the Haxe website at haxe.org and click the download link provided on the landing page. For older libraries, it might be necessary to use an older version, which can also be found on the website. For this tutorial though, we will be using the newest version, which is 4.1.2. Choose the installer for your operating system, and once it's ready, open it and begin the installation process by following the prompts in the install wizard. By default, the setup will encourage you to install the most relevant version of Neko, which will be important later on. Select the destination for the Haxe toolkit and continue to finalize the installation. Go ahead and wait for that to finish. Alright, Haxe is installed. Next, we need to install an IDE. Of course, you can always use many popular ones like IntelliJ or VS Code, but for the sake of simplicity, we will be using HaxeDevelop. Look out for future videos in which we will walk through setting up both of these popular IDEs. HaxeDevelop can be found at haxedevelop.org. Go ahead and download the installer from the main page and then run it. When the installer loads, you might get a prompt about the latest version of Flash Player. If you don't already have it, you can probably ignore it for now, but it might be handy for convenience later on. Next, you might get a prompt about the 32-bit Java runtime, and if you don't have it installed on your machine, go ahead and do this now before you continue. If you've already have it, go ahead and click Next and continue the installation. Alright, we have HaxeDevelop. Now that we have Haxe and HaxeDevelop installed, let's install OpenFL and its dependency Lime using the HaxeLib command line tool. I don't plan on touching on Lime much in this video, but I promise to go into depth about Lime at a later time. Go ahead and open your command prompt. If we call HaxeLib at the command prompt like this, it should display a list of commands that you can use with this package manager. Now we want to go ahead and type in the haxlib command install. And then since we're trying to install OpenFL, go ahead and just type in OpenFL. And as you can see, it's installing. Now we're going to need Lime. So basically do the same thing, haxlib install Lime. And it's finished. There, that was quite simple. Now we have our environment set up. For a complete look at all the libraries available on Haxlib, you can check them out at lib.haxe.org. While you don't actually need it unless you plan to publish for the Windows platform, the last thing I want to do for now is install the Windows Sdk, since we're going to be testing a few different targets, including C++ for the Windows platform in just a minute. So go ahead and download the Windows Sdk from the Microsoft website or Visual Studio. Follow the prompts. Accept the agreement. Install. And we'll speed this up a little bit while we wait. And there, the SDK is finished installing. Now we have everything we need to continue forward. Let's go ahead and open HaxeDevelop. Now, we could run some of the samples that come with OpenFL in the command line, but I'm going to skip that for a later video. Now that we have HaxeDevelop open, let's go ahead to the project menu and select New Project. Then, OpenFL Project. Rename your project. Click OK. As you can see, most of the boilerplate code has already been generated for us as we look into the main class of our project. A bit of commented code example has already been inserted in the main constructor. This gives you a little insight as to how external image assets are loaded into your project, but we won't be getting into that much in this video. So go ahead and delete this. And now let's take a look at our application's main configuration file, which can be found in this project XML. As you can see, we have a short list of configuration options relevant to our application. There are many more options and ways you can configure your project, but this is the bare minimum required to run or build the application. Here we have the window title, the package, the version, and the company parameters. Down here, we specify our main class, which is coincidentally main. Then there's the file output name, and then the path to the build location. Further down, we have our background setting and frames per second, followed by the window width, window height, and a conditional argument that determines whether we should use these particular configurations. In this case, it means set Windows width and height to these values unless we are publishing for mobile. This is a powerful means to configure your project in a way that it runs where you want it, no matter where you're publishing to. Next, we have the window orientation, vsync, and anti-aliasing, which are only set if we are publishing for a CPP platform as shown by the conditional here. Down here, we have the source path, and then our included libraries, which in this case is just OpenFL. As you add more libraries to your project, be sure to add them like shown here. Finally, we have the icon path, and then the assets path. Rename is used here in order to simplify the actual path location when referenced in your code. Now that we have a basic understanding of our project configuration, let's hop back over to our main class here. Note that when we extend a class like Sprite as shown near the top, we always have to call super on our constructor. If you're coming from a Flash background, this should look pretty familiar except for some subtle differences that I'll talk about later in this video series. Let's think about how we would print an output in AS3. If you don't have a Flash background, that's okay. You should still be able to follow along perfectly. In AS3, we simply call the trace function like this. Alright, now that we have a little bit of code, let's run it and see if it works. Up here we can choose our build target. First I'm going to select Neko, which is the VM I mentioned earlier. While you can certainly use Neko in production, I find most people simply use it during development as it builds very quickly. Now press F5 or click the Test Project button to run our project. And there we have our trace statement. Easy, right? I was actually quite surprised at the amount of time that took. It's important to point out that I'm doing this tutorial on a Windows virtual machine with limited resources. Under normal circumstances, it should be a bit quicker. Now let's try to run our project in the browser. Go back to the drop-down and select HTML5, and then Test Project. Alright, now let's check the console. And there's our hello world trace statement. Alright, Now let's try to build our project for native Windows. First though, we need to open the command line again and install HaxeCpp exactly the way we installed OpenFL in line with HaxLib. So, open the command prompt, type in HaxLib install HXCPP. Alright, now that the latest version of HaxeCpp is installed, we can go ahead and close this, head back into HaxeDevelop, select Windows, test project. Now this is going to take a little bit, so we're going to speed this up in the video. And there's our trace statement once again. As you can see, that took a little bit of time, and now you probably understand why it's important to use Neko during testing. Okay, before we finish this video, let's take a quick look at drawing a few things to the stage using text field in the drawing API. Go ahead and close this. Switch back to Neko. Remove this line. Let's import OpenFL .text field. Down here, we'll type there text field. Type is text field equals new text field dot background equal true text field dot text equals hello world, add child text field. Test project. And there you have it. Pretty simple, right? Now, let's go back and draw something with the graphics API. Shape, type is shape, equals new shape dot graphics dot begin fill, insert color, shape dot draw. graphics dot direct 100 by 100 by 100 by 100. Add child shape. Test project. And there you have it. If you have any questions or you'd like to come and talk to us about Haxe or OpenFL, feel free to chat us up in the official OpenFL Discord server. Well, that's it for today's tutorial. Hit the like button and subscribe, and we'll see you next time. Thanks for watching.